Finite element analysis is used in many different applications to determine the stresses and strains which are present in certain materials. In this image here, we see how finite element analysis is used on a windmill. Finite element analysis is defined as using a computer model of a material or design to test stresses due to various forms of loading. In our experiment, we'll be using strain gauges which will measure the vertical and horizontal strains on a material that we're analyzing. We will be using the data from these strain gauges in conjunction with photoelastic visualization to determine the stresses and strains which are present. To conduct our experiment, we'll be using an Instron machine shown here. We've completed finite element analysis in SOLIDWORKS for the prediction. This here is the mesh that we use for the piece of the material that we were analyzing. This image here shows the finite element analysis completed again for that piece of the material. As we can see, there's a high stress concentration at the point of minimum area of the plate. The series of images here show photo visualization for polycarbonate being unloaded. As you can see, there are different colors which are different fringes on the element. They show different amount of stress that we're experiencing while completing this experiment. The graph here shows the predicted stress concentrations within the polycarbonate plate in the y direction, that being the vertical direction. As we move from left to right on the graph, we're increasing the distance that we are away from the hole in the plate. As you can see, the graph decreases moving from left to right. This is because the stress concentrations around the hole are the largest, whereas far away they are the smallest. The graph here with the red line is showing the actual data which we had collected from the experiment, similar shape to the graph which we have predicted. This graph here shows the stress concentrations of the polycarbonate plate in the x or horizontal direction. As can be seen, no real trend can be derived from this graph, which is probably a function of getting poor data from the strain gauges. In this experiment, we've seen how finite element analysis and photoelastic visualization are very good representations of the different stresses which are present in any given material. We've also been able to derive a relationship between the distance from a hole and the stresses which are present in a material. As we can see from the graphs that were previously presented, the farther away from the hole that you get, the less stress is present. This is an excellent representation of St. Venant's principle.